Hello everyone, welcome to this overview of XTiled, a XNA library I've been working on for parsing tiled or TMX maps. I want to give an overview of the features. You'll see briefly a platformer I'm working on, but I just want to kind of do a video of some of the features that I've been working on. The first thing I'll do is I'll just start off and show the platformer here. So this is my platformer. You can see we've got slope there that we can move up and down, jumping, collision detection's working, so pretty basic here at this point. And then I also have some moving, oh, just died there, of course, the one time I go to record it. There we go, some moving platforms. So there I've got a horizontal. Coming up here I've got two vertical moving platforms, and the key is here that they stay synced. So you want to make sure that they, keep time. Got a diagonal moving platform over here, and I just missed that one. That is the big long platform. It'll come back around in a minute here. Just missed it. We'll ride the little one for a little bit. Platformer working title is Jasmine's World, but that's our working title. May change it. And so I'm on the last platform here to show that following a path is also an option, and suicide. Alright, so that's basically the game. Let me show you the map. So this is the tiled map editor. I did not make this. This is an open source project that you can go and grab. It is over at mapeditor.org. You just come here and download it for Windows, Mac. I believe, Ubuntu. You can get Linux, and pretty much has parsers for every game language you may use. And I am not the only XNA language. What I'm going to show is XTiled, the one I have been working on, which is open source. It's available on Bitbucket under vinyl, vinyl/xtiled is the URL to go grab that. So this is the map. Of course, I've got a lot of tiles on the map, and pathing and everything going on. I'll just turn off all the special layers just so you see the tiles. I've got several tile layers here, one for the sky. The tile set that I chose was an interesting one in that if I get down here I can show you what an individual tile looks like. Let's go to my tiles. There we go. And let's zoom in here. So each one of these is a tile out of itself. So this is a full tile from here to here. However, the player kind of understands this segment up top here, that little piece, as the tile. So I chose this because it's got a nice offset and will use some of the more advanced features of tiled. And I wanted to make sure in XTiled that I had them implemented correctly. Alright. So that did create a bit of a problem though, because in stacking, that's why I had to make all of these layers for the tiles to stack up appropriately as you go up. You want them to stack on top of each other. If you set them, you can see here. Alright, so there's my layer for these blocks right here. And if I come over here and grab another one of these blocks to place, and I line it up about where I expect it to be, you can see that it actually falls behind. You'll need to go up a layer to place that appropriately. So I'm just going to get rid of that now. So Tiled's a great map editor. Highly recommend checking it out. In fact, one of the reasons that we built XTiled is that we're big fans of this. So the first thing that I created in here was the platform zone. So rather than doing collision detection based on the tiles, because again, my tiles aren't really set up for collision detection. I have to do a lot of adjustment. I just went in here on the platform layer and drew some objects Let's see, I can go here and show you that real quick. Just draw some objects there, and that creates a collision zone in the map. So also, you can draw polygons. So if you want, like I have down here, a polygon that has a slope in it, so that you can create angles and such like that, and I'm not just limited to square tile collision. Get rid of that. Alright, so I created that, and then also I did the same thing for the death zones. So these red areas, if I collide with that, would be death. Nothing special there, done the same way. Could also do it with polygons if I wanted. And then I have a layer for map items. The only map item I have right now is the player start. If I look at object properties, I named it player start just to be able to find it and reference which character the player should be from the ones that were in here. This tile set is not one that I created, by the way. This tile set is available at lostgarden.com. Check it out. The man behind Lost Garden does a lot to support indies, and creating some of these tile sets is really cool. Alright, so the next layer of interest is the moving platforms. And what I did on the moving platforms is I basically made it 3 components. So to have a moving platform, you need 3 things. You need the collision box, you need a polyline, which is the path, and you need a sprite that'll represent it. And on each one of these, the name should be the same. So A will all match those up in code. Since XNA likes to use the top left coordinate of the rectangle, we're gonna line that up and just let the polyline go from here to here. It will actually finish in that position because this is the top left movement. So it just helped to visually place that. And then, of course, where we want this in reference. This tile I want to go back and correct. You can see that the platform collision box is right along there, and I want to kind of move that up a little bit on this tile. That's just some graphics I'll fix later as we go on. So I don't want to save anything, so I'll have to rebuild. So then the same thing here for the vertical ones. I just drew the line in a different direction, B and C, and then one at a diagonal. And this was just to make sure all my logic was working. And this one actually has several line segments, so the platform, as you saw in the game, follows all the segments. So that's really the map. That's all the features of Tiled that I'm using at the moment here. So the first feature that, hey, we made some changes, and I don't want to do that, so revert those. The first feature that I've brought in with XTiled, which I will give you a real quick. XTiled, if you've not used Content Pipeline before, is going to be in, you can download the XTiled directory and unpack it somewhere. You'll have the tiles extensions, which you add as a reference to your content pipeline project, your content project. And then you add a platform-specific Xbox or x86 DLL. You want to leave the XML in place to get IntelliSense hints. But then this one then gets referenced by your game code. So you add a reference to that DLL in your game, and then you're set. You're set to use Tiled. And then once that happens, TMX maps, as you add those, will show up here as the TMX importer and the TMX map tiled for the content processor. Now, don't mean to make you dizzy, but let me zoom in, zoom out. Okay. The first thing that I'm doing here, actually it was turned off by accident. Let me make sure I'm doing that. I don't want to say something that's not true here. Build starting. Take a good time for a tea. I thought I actually had this option turned on, and I do. Okay, so I'm good. The first option that I am overriding is load textures is false. So when you have your TMX map file, it'll reference your image files, and you can tell XTiled not to load those textures itself, and you will manually load them. Why would you want to do that? Well, if you have several maps for your game and they utilize the same sprite sheets over and over again, you would want to save yourself the trouble of loading and unloading the same sprite texture sheet over and over again. If you are loading the textures, then you can change the format to color or DTX compressed, or no change. Your standard texture options are there. Pre-multiply alpha is also there. XTiled under the hood is just going to use the standard texture content processor for all your sprites, so nothing new really happening down there. But you can turn it off. So in my game code, the line right here is loading the map, and no different than any other content. You just load the map, reference it in the content project. You will need to have a reference to Funkworks XTiled. You may wonder why we put our name of the company Funkworks in the namespace. We're not advertising. We're not trying to be good. You notice that Microsoft has their name up here all through that too. And when you're distributing a third-party library, it's good to go ahead and put like a company name or a project name or who's building it name in there as the first part of the namespace. So it's an open source project. If you want to take XTiled and modify it, change the namespace, and then we won't have any collisions. You know, you can put your name at the front instead of Funkworks, and then we don't have any collisions to worry about with other names and things like that. Okay, sorry, that's details. So when we load the map, we do need to go down here, and I'm going to show you that in my game assets folder that I'm loading, you can see I'm loading all those sprites here, because again, I turned that off manually. And once I have all those sprites loaded in my level initialize code, I will check all the tile sets here in the current map. Current map is the XTiled map, so that guy right there is the XTiled map, and he's got all the tile sets for with him. There's a image file name which tells you the original image that it was referenced to, and then I can just go through here and assign my textures to the tileset textures. This lets me use the built-in XTiled drawing functions, even though I haven't loaded the textures with XTiled. Down below here, some bottom code you can see. Oops, I didn't mean to zoom out, but why not? So down here, you can see I'm also running through all of my object layers. Those were the layers of interesting things on them, and basically checking the names and then saving an index into those layers. So I just know what the platform layer is, what the moving platform layer is, and etc. So to show this in action, down here, the level is going to handle, my level class is going to handle most of the rendering. And I will show you real quick how the level does its rendering. So it's all handled in the default XTiled draw method, which all you have to pass into it is a region of the map. This is in map pixel space for it to draw. The XTiled library will assume that you're going to map that region to 0, 0 on the screen, and that the height and width of that region are the height and width of the screen. If you're wanting to do an inset map, we went down the road, I had some code that did that, calculated it and stuff like that, but actually what I found out in testing was if you're using XNA, you can set a viewport if you don't want to draw to the full screen, and then just have the map draw to the viewport much better code than what I was coming up with. So even though I'm assuming the full screen when you pass that in, that'll work with a viewport if you want to draw to a smaller section. Now I've got some debug statements here that I haven't shown off yet, and I will here in a second, that will draw the object layers. So this is one feature that I have added in, that this is going to draw my depth layer and my platform layer. So essentially if I set show collision to true, I can see where the collision boxes are. This one isn't something of specifically to XTiled. Down here, the active zone is the zone for pushing the screen and scrolling the screen. So if I want to see that, I could set active zone to true. Now I am using a draw rectangle helper method in XTiled to just draw a rectangle on the screen. Again, most of the methods are going to take in a region. So when I give it the region of the zone to draw in, this is always in map space. We're always dealing in map space, and then we're passing in the map region that's on screen and letting XTiled figure out and translate that back to screen space. So far, that has always been the most useful in the common case, and I haven't added overloads to allow you to do your calculations. But we may add that in the future, but for right now we don't. For the last part, each moving platform, I've created a custom class, and I'll show later, that's handling all the moving platform drawing. So again, to run the game and show off now, this bit here I'm using the XNA performance toolkit, I think is what it's called. Has some cool little things like an FPS monitor in it. I got a little ruler at the bottom and some data that tells you how long I'm spending in draw and update. You can see I'm taking up no time to render the map right now. Full disclosure, I've got like 12 gigs of RAM on an iCore 7, so this isn't a fair litmus test, but although I have run on the Xbox and made sure performance is good. But anyway, I'm going to set show collision to true. The other feature of the performance toolkit is this debug console window that allows you to hook in and add your own. So here we go. Let's turn off the time ruler log. So here we go in a debug mode now. You can see the yellow collision detection is my player collision boundary, and then you can see how he moves along just fine, and you can see when he hits the dead zone, he's dead, back to the beginning, and you can see how that's going. And then also we'll see here the collision zones on the moving platforms as well. Now, you may wonder, it's like, hey, check out the cool colors. So the colors actually came from the color setting for the layer in Tiled. So if you color the tiled map object layers, that will by default show. Alright. So that's one of the cool things that I added in there beyond the basics was some of the map rendering by region, and then also being able to draw object layers like that. Now, if you want, there are overloads for drawing their individual tire layers and things like that. The level class here does handle moving the screen around, but it's actually the player class that deals with the player movement. And for my collision, I should call out a little bit here how my collision is working, because I'm a recent convert to this style of collision detection. So essentially what we've got going on here is that what we check is we assume that the world is in perfect harmony and nothing is colliding with nothing. And then we take some input here. So here the player input is taken for the x-axis, whether we're moving to the left or the right by gamepad or keyboard. I haven't refactored that into its own class yet. So we figure out what we want to move. And then this little check right here makes sure that, yes, we have a move. Okay, so we want to make sure that first we are moving. And then we're going to go through each object in our platform layer, and we have this little helper method, get objects in region, which on the map will take in the region. In this case, player move is the bounding box adjusted. So player bounds is the current location, and player move is the location we want to move to. And we run through each of those objects. Now, here's the cool part. If there's an overlap in the player bound, then we have a collision. I don't need to actually check an intersection or anything like that because I've specified not all the objects on screen. I don't need all the objects on screen. I only need the objects within the player's zone because he just moved X. And then I adjust and correct for the X only. Later down here, we decide if we're going to jump or not. If we're jumping or we're not jumping, we define whether we're going up or whether we have gravity. And then we do the same thing down here. We go through each object, and this utility class, in both cases, returns a Boolean if we actually collided. So why would that happen? Well, what if we collided with a polygon? Then the rectangular intersection that the object and region will intersect with is going to return the polygon because the polygon bounds are in the region, but the polygon shape itself may not be. So my method here will actually check that if we are colliding in the Y, then we are done jumping because we've landed. And this is why I'm a fan of these micro collision detection steps of do one thing and then resolve collision, and then do the next thing and resolve collision. Now, one is I always get to assume that the world is in perfect harmony, and then whatever I've done, I'm the only one that has done it, so I don't have to worry about having an X and a Y collision at the same time and having to resolve both. I can resolve them one at a time and know the intent. The second one here is that I want to go through each of my moving platforms and also do the collision with it. And like I said, those aren't map objects in the current map. Those are custom classes that I have created. Now, I'm going to take a look here at this adjust location method, because that has some XTiled help in it as well. Let's jump over here to the definition. So this is the Y version of this method, and the first version here simply just takes in a map object, which is an XTiled map object, and checks to see if it's a polygon by seeing if there's something in the polygon value. Currently in tiled, you won't have like a sprite and a polygon be the same map object. They'll be of a singular type. So that's okay here. If they ever allow multiple types in an object, then it'll be kind of cool because I could combine my platforms into one logical object. But I would have to update my logic code here. So if that's not equals null, then there's a polygon, and I'm going to go ahead and do polygon collision. If not, I'm going to do just regular bounding collision. The second one here takes a general rectangle, which is this one, so that will connect down to there. And it simply uses the rectangle. This is all XNA here. Just use the rectangle, get the amount of intersection, and back out that much. That's all I'm doing on the Y. This last one here takes in the polygon. Now what I'm doing here, mostly all XNA, but I have added some methods in XTiled to make this easy to work with polygons, because XNA doesn't have a polygon object. It doesn't have a line object for that matter either. So the first thing I want to figure out which point of the rectangle that we're colliding with is actually the offending corner, right? So this loop here goes through and finds the offending corner. Whichever one of these is inside, which the polygon is now the platform, so the platform has a contains method. So I've made the polygon objects behave just like the XNA contains and intersects method, and has an overload that takes a vector. So I'm passing in a vector of each corner of the rectangle. I'm not doing point collision at this point. I'm not doing points because they're integers, and I want to make sure that we are okay if we are colliding by half a pixel, say. Okay, so once we found that point, this is the real reason we're interested in vectors. we take the vector of the rectangle and then the vector of the center of the object, and we create a line. So real quick here, if I do this key command right, I'm going to go to a whiteboard. There we go. So, you know, let me get, there we go. So real quick here, here's our rectangle. That's our player. And it's a horrible rectangle, but whatever. He is colliding with our platform here. Okay, this is our polygon platform that we're colliding with. Alright, so what we're doing is we're getting this point here and the center, and we're making a line. Alright, and then essentially what we're going to do is we're going to take this line and this line and get that point right there, and that will tell us how much to back out of the collision. Now, remember that the collision is broken apart into X and Y separately, so we know we don't actually need to back out both directions. We only are going to back out in the Y direction going up. The reason that I broke them out X and Y, and the reason I like this approach again, is if I did both, the player would slowly fall down a slope. And that's not what I wanted for this game. That might be more true to gravity, and if you were doing a ball game, that might be what you wanted, but it's not what I wanted in this case. Alright, let's get out of that. So, that little bit that I explained there, we get this line here. Then down here, we set up an intersection. So, when we do our intersects test, we have an out parameter. So this will return a boolean if it's true. We intersect, and it sets the point of intersection, which we can then calculate our delta. That's horrible. Then we can calculate our delta box just like we would if it was a rectangle. But then down here we only adjust for the y because that is this version of the method. If you wanted the x version is up here, does the exact same thing. So that is some of the helper methods that have been added in to XTiled to get all that to work. And then the last thing worth looking at here is the moving platform, which I construct a moving platform. Like I said, it has three map objects: a tile object, a path object, and the platform object. From the tile object, the tile ID may be null, so it's a nullable, but I know in this case it's going to be true before I hand it in. This gives me my source tile ID, which I can look up later. I'll show you in the drawing code, because I kind of hand draw moving platforms myself. Tile location, so this is the bounding object of the tile, so this just helps us draw it. And the platform is this one down here. So again, this is the collision detection platform, and this one is the sprite. So they're separate so that I can deal with them independently. And then of course the polygon, that is our path. And then we call initialize, which calculates our offset of how much the sprite is drawn in relationship to the bounding box, so we can keep that. What direction we're going, what line on the path we are, how much we've changed. And then zoom out here to the update cycle for the moving platform. Essentially, we determine that, hey, if we've moved past the end of a line here of one of our line segments, then it's time to flip directions or move on to the next line. So not a whole lot going on there. And then sorry about that. Again, I don't mean to make you dizzy. And then here, this essentially gets us a percentage of how far along the current line we should be. So, just a basic distance equation using vector 2's. Nothing special going in there. We take that and then we pass it in here and do a linear interpolation, a lerping, if you will, to get where we want to be. And then we figure out what the change is. Now, change is a point because we actually do have to change in whole pixels, right? So when it gets baked down, we move in whole pixels. So we go ahead and figure out what the new position is going to be in X and Y and integers because it's going to be cast down here. So the new position is, and then we calculate the tile taking in the tile offset. The reason for needing it in pixels is though, again, the world was perfect before we moved, but we might have touched the player. Now this isn't the ideal way. This was my quick and dirty way to do it. I'm going to come back and improve this later. But essentially, I made a copy of the platform and inflated it 10 pixels in all directions. And then see if the player was above me, basically, on the platform by seeing now if the player intersects with that position. And if he does, I've got my change values. And then I can move both the player location, which is the sprite, and the bounds, which is the collision box. Alright. Down below, we've got the draw call. And like I said, this will give you some insight into how, if you wanted to manually render some tiles or something, how you would do that. So, essentially, again, the current map is our XTiled map that we've loaded. We have a tile set array, and source tiles are a list of all tiles across all tile sets. So when we have our source tile ID, we actually have to look it up in the source tiles array to get the tile set ID, to get the tile set it belongs to get its texture. Alright? A lot of lookups there, yeah. Can be a little convoluted. I'm toying around with different ways to make that simpler, but at the same time, I don't want to make a whole bunch of copies of stuff that aren't needed. So then the next part we have to do on Sprite Brush, we have to tell it where to go on the screen. So like I said, all the methods take in the map region, so I'll have the map region. And if you pass in translate, this is a static function that you can call, pass in the location that you want to translate, in this case the sprite location, in world coordinates, and what the region is on the screen, and that'll pass you out a screen, just translated position for your map object, or whatever rectangle you passed in. Alright, let's go down here. Now, our source tiles, again, this source here is a rectangle that tells us on the tile sheet texture where that source tile comes from. Forget color white, no rotation. I'm not doing anything special there. Then this bit here, just like we have source connecting to that, we have an origin point that may be set to some other value. Many times it's set to the center. This is to support rotating tiles on tile layers and flipping tiles on tile layers, something you can do in Tiled, the map editor. So we need to support that. So the origin many times is going to be the center, so that those rotations and effects work. So you need to take that into account as well. And then no sprite effects, and I'm not using layer depth. And then again, if we're showing the collision detection, I get the current object layer color value if it's set. If not, we use white. Doesn't have to be set. And then I made a copy of it down here so that I could make the fill a little transparent. And then again, this is the draw rectangle helper method. Pass in the color and my fill, and that is rendering the map objects. So that really, in a nutshell, is a good overview. There's a lot more features that you can get into with the map editor, as far as rendering individual tiles or getting subsets of tiles out. If you go onto the wiki from the Bitbucket page, there's extensive documentation that we have up. Object reference has all of these methods that you can get into here, and what the all different properties and everything are. There's tons of things that can have tons of properties and things like that. If you can set it in the Tiled map editor version 8.1, then right now we have support for it in XTiled at the time of this recording, but we will stay up to date as best we can when new versions roll out and new features come along. So this also walks you through here a little simple game to get going and just render a basic map and what that would look like as well. Alright, thank you for watching, and if you have any questions on getting XTiled or using it, you can ask in the video below, but really if you go to Bitbucket there, here in the About section, we have a Google group. There's a link to it right there, so it's probably best to go to the discussion group and ask any questions there. Thank you for watching.